All right, so just continuing on, we're going to rewrite the following with the lowest prime base. So you may ask yourself, how do I get to the lowest prime base? And really just factor it until you hit all prime numbers for factors. So some of us are able to recognize that 20 or 125 is really just 5 to the power of 3. 5 times 5 is 25 times 5 is 125. Or we could split it up into its factors, 5 times 25 and 5 times 5 squared, so it's 5 to the power of 3. Let's move on to the next example. 4 to the power of 5. If we want to reduce 4 to its lowest base, that would be 2 squared. So 4 to the power of 5. Now we would use the power of a power rule and simply multiply our exponents, which would give us 2 to the power of 10. Moving on to the next example, 1 over 49 squared. If we're going to rewrite that with the lowest prime base, I would maybe want to rewrite this as 49 to the power of negative 1 squared. And I recognize that 49 can be written in its lowest prime base as 7 squared. So 7 squared to the power of negative 1 squared. So the power to the power to the power rule would mean that we just multiply our exponents. So really 2 times negative 1 times 2, this would be equal to 7 to the power of negative 4. Really important skill to write a number into its lowest base prime when we're solving exponential equations. So let's solve the following by changing the base. Now, here's a little known fact, actually. 27 to the power of 2/3 is equal to 9. Very few people know that, and it's kind of hard to even do that off the top of your head. So what we're going to do is each of these numbers, we're going to change them to the lowest prime base. So when I look at my base here, I have 4 and I have 8. The lowest prime base, I think, will be 2. So really, there's 4 to the x minus 3 is equal to 8. So I'm going to, on the left-hand side, I'm going to use the power to a power rule and multiply the exponents. So 2 to the power of 2x minus 6 is equal to, 2 to the power of 3. Since the left-hand side and right-hand side are equal and they have the same base, I can just simply state that their exponents are equal. So now allow me to find the rest out here. So 2x, if I add 6 to both sides, 2x is equal to 9. If I divide both sides by 2, I get x is equal to 9 halves. Now, something that I would never have guessed if I was to make one. So let's move on to the next one. 9 to the power of 4x is equal to 27 to the power of x minus 1. Well, I'm going to change this to the lowest prime base. And the lowest prime base, if I look at my base, I have 27 and 9. I ask myself, would they have the same prime base? I certainly hope so, because otherwise I'm out of tricks. So the lowest prime base is 3. So there's 9 to the power 4x is equal to 27 to the power of x minus 1. All right, I think I'm just going to clean stuff up here. We're going to use the power of a power rule and multiply the exponents. So 3 to the power of 8x is equal to 3 to the power of 3x minus 3. Just be very careful to distribute your multiplication. So since both the left-hand side and right-hand side are equal and the bases are the same, we should have 8x is equal to 3x minus 3. I'm going to isolate the x's on the left to the left-hand side. So I'm going to, if I subtract 3x to both sides, so I have 5x is equal to negative 3. If I divide both sides by 5, we end up with the result x is equal to negative 3/5. Whoa, is this the... Oh, great, this is the last question. I was going to solve this. I think I'm going to save it for the next video. But maybe, just maybe, try to figure this one out before you